Hello everyone, welcome to CS for All. I am your host Sunyul Hossen, and today we are going to talk about experimental analysis and BIGO notation. So in the first part of the video, we are going to talk about experimental analysis. I will actually teach you how to measure runtime of an algorithm or the execution time of an algorithm. So let's get started. Now I have written this particular block of code for you. Every programming language comes with a library which helps us to measure the timestamp. C++ comes with library ctime. This is a library for C++ programming language. Now coming to this block of code, we want to measure the time taken for the sort function to run or execute. The start time will contain the timestamp at which line number 20 is getting executed by the compiler, and the end time variable will contain the timestamp at which this line number 22 is getting executed by the compiler. And in between the start time and the end time, we have the sort function which is getting processed and requires some extra time. So the difference between this end time and the start time will actually help us to know or measure the execution time of the sort function. So if I say the start time or the starting timestamp of this line is 120 milliseconds, and the ending timestamp of this line is 150 milliseconds. So a difference between this ending time and the starting time will actually help me to know the runtime or execution time of this complete sorting function. So here the difference is 30 milliseconds, and 30 milliseconds would be the execution time of the sorting function. Now this sorting algorithm is an ideal merge sort. Let's see how much time the code takes to execute for a given vector of size 100. So it takes 0 milliseconds to execute on my machine. It can take different milliseconds for your machine. So I have built this table to compare the runtime between two algorithms. One is the merge sort and one is the bubble sort. The merge sort is an n log n algorithm, while the bubble sort is a quadratic algorithm, that is n square algorithm. So for 100 size input, we have got runtime of 0 seconds. So let's write it here. So the runtime was 0 milliseconds. Now let's check for an input size of 1000. So now let's give an input of 1000 and check how much it takes to execute the code. Okay, so it takes again 0 milliseconds to execute the sorting function. Again, it can be different for your machine. So let's write it up in the table. So we will write here again a 0 milliseconds. Now let's check for an input size of 10,000. So let's change it to 10,000 and see how much milliseconds it takes to execute. Okay, so it takes 2 milliseconds this time to execute the sorting function. Again, it can be different for your machine. So let's write it up in the table. So let's write 2 milliseconds for an input size of 10,000. Now we will check for an input size of 1 lakh. So let's add a 0 here and check how much time it takes to execute the sorting function. So this time it takes 20 milliseconds to execute the sorting function. Again, it can be different for your machine. So let's write it up in the table. So let's write 20 milliseconds for an input of 1 lakh. Now we will be running the algorithm for an input of 10 lakhs. So let's add a 0 here and see how much time it takes to execute the code. So this time it takes 208 milliseconds to execute the sorting function. So let's write it up in the table. So let's write 208 milliseconds for this input size of 10 lakhs. Now we will write the bubble sort algorithm and compare the runtime with all the runtime of merge sort algorithm and see which one is better. So this is the entire bubble sort code, and we will check with an input size of 100 what is the execution time of this bubble sort. Let's build the code. So I get an execution time of 0 milliseconds here. So let's write it up in the table. So execution time of bubble sort for an input size of 100 is 0 milliseconds. Now let's check the execution time for an input size of 1000. So let's add a 0 here and try building the code now. So the execution time for an input size of 1000 is 17 milliseconds in case of bubble sort. So let's write it up in the table. So let's write 17 milliseconds here for an input size of 1000. Now let's check the execution time for an input size of 10,000. So let's go to the code. Now let's increase a 0 and check the execution time for an input size of 10,000. So the execution time is very large, it's 1330 milliseconds. So let's write it up in the table. Let's write up 1330 milliseconds for an input size of 10,000. Beyond this point, if you are going to run the bubble sort algorithm for an input size of 1 lakh or 10 lakh, this is going to be huge. This will take infinite amount of time. So we don't have that much time. So we will just write here infinity. And same for this 10 lakh input. So we can see the execution time of the bubble sort algorithm is almost doubling up at every particular step. But the merge sort is not growing that fast. So this is a reason we should focus on learning how the n log n and n square comes instead of just doing an experimental analysis and finding absolute time for every algorithm. So the growth factor here in merge sort algorithm is almost n log n, and the growth factor in the bubble sort algorithm is almost n square. So this is something which we should always avoid, and we should learn the n log n and the n square analysis, that is a theoretical analysis. So we will be learning about all this theoretical analysis in the next chapters. So that's it for today. If you had any doubts or issues regarding the lecture, you can write down in the comments below, or you can directly reach out to us through LinkedIn. We will definitely try to resolve them. And if you enjoyed the video or found the video helpful, please consider liking and subscribing to the channel and share it with your friends. So see you guys in the next video. Stay happy, stay healthy. Bye. It's my life.